All right, let's solve another differential equation using the Laplace transform. This one's going to work out a little differently than the last examples. So we have y double prime minus 10y prime plus 26y equals 0. Initial values are y of 0 equals 3, y prime of 0 equals -2. So again, we're going to take the Laplace transform of both sides. We're going to split it into 3 Laplace transforms and we'll factor out the constants. And Laplace transform of 0 is 0. Right, Laplace transform of y double prime, that's going to be s squared Laplace transform of y minus s y of 0 minus y prime of 0 minus 10 Laplace transform of y prime, that's going to be s Laplace transform of y minus y of 0. And we've got plus 26 Laplace transform of y equals 0. Now let's plug in our initial values. So anywhere I see a y of 0, I'm going to plug in 3. Anywhere I see a y prime of 0, I'm going to plug in -2. So now I get s squared plus transform of y minus 3s plus 2 minus 10s plus transform of y. And it looks like that's going to be plus 30. Got -3 times -10. And then I've got plus 26 Laplace transform of y equals 0. So anything that does not have Laplace transform of y, that's going to get moved to the right side. So it looks like I've got a plus 2 and a plus 30. So if I move that to the right side, that's going to be 32. And then I've got minus 3s. So I move that to the right side, that'll be plus 3s. So the right side's going to be 3s plus 32. Actually, that should be minus 32. I moved it, right? Moved it over. Okay, and then everything else has Laplace transform of y. We're going to factor that out. And I'm left with s squared minus 10s plus 26. And I'm going to solve for the Laplace transform of y by dividing by s squared minus 10s plus 26. So the last examples that we did, this denominator factored pretty easily, right? This one does not factor with real numbers, okay? So if it doesn't factor, then what you should do is complete the square. Okay, so we're going to complete the square on just the denominator, right? So to complete the square, you're going to take the middle term, the -10, divide it by 2, that's -5, and square it. So that would give us 25. So I need a 25 to complete the square. Now I have a 26. So let's just turn that into s squared minus 10s plus 25 plus 1. So this is a perfect square. So this becomes 3s minus 32 over s minus 5 squared. Sorry, I'm trying to write 10 there, but it's s minus 5 squared plus 1. So what this looks like to me, if I look at my Laplace transform table, it looks like a sine and cosine, and it's been shifted. And it's been, shifted by 5. And it looks like a is 1, so it's a squared here is 1. So I've got to get an a over s minus 5 squared plus 1, which would be 1 and 1 here for a and a squared. And then I've got to have an s minus 5 over s minus 5 squared plus 1. Okay, so I've got to somehow come up with a 1 over s minus 5 squared plus 1. I've got to come up with an s minus 5 since it's been shifted, right? You got to shift the s's, right? You got to subtract 5 from all the s's. So it'd be s minus 5 over s minus 5 squared plus 1. So I don't have to do partial fractions here, but I'm still going to split this into two fractions. I've got to have a sine and a cosine, right? So let's just move 3s and negative 32 apart, and we'll just deal with that. All right, so on the right side, I need 1 over s minus 5 squared plus 1. On the left side, I need s minus 5 over s minus 5 squared plus 1. So to get the s minus 5 on top, I need this to be 3s minus 15. So then I could factor out a 3 and have s minus 5 left over, right? But if I do that, then I need to add a 15 over here, right? So that I'm not just throwing in a 15. So I'm going to factor out 3, and I'll have s minus 5 over s minus 5 squared plus 1. And then on this side, negative 32 plus 15, that's negative 17. So let's go ahead and factor that out, negative 17, and then I'll just have 1 over s minus 5 squared plus 1. So now when I take the inverse Laplace transform, I'll get y on the left, and then this will be 3. This is the cosine version, but it's shifted by 5. So it's going to be e to the 5t, and then cosine of at, which a here is just 1. And then I've got minus 17. This one's the sine version. Again, it's shifted by 5. And then a is 1, so I just have sine of t. So that is my solution. And that's a tricky one. So just remember, if the denominator doesn't factor, you're not going to use partial fraction. You're going to complete the square and then try to create this sine and cosine pattern.